The sequential state bottleneck. The global state model used by almost every major blockchain today is reaching its logical limit because it forces every user to wait for a single sequential ledger to update. This design choice creates a permanent bottleneck where transactions must compete for the same narrow window of execution, leading to the fee spikes and congestion we have seen on Ethereum and Solana for years. Anoma's Resource Machine takes a different path by abandoning the concept of a shared account ledger in favor of a model that treats the entire network as a pool of atomic resources. This shift suggests that the future of scaling is not about making a single sequencer faster, but about making the state itself more modular and asynchronous. And the structural mechanics of how these resources are consumed are even more interesting than the speed benchmarks. Consumption versus state transitions. Instead of updating a balance in a database, the resource machine uses the logic of creation and destruction. Think of it like physical cash rather than a bank statement. To send an asset, you do not update an entry. You destroy an existing resource and create a new one that only the recipient can spend. Because these resources are independent entities, they can be processed in parallel across different nodes without ever touching the same memory space. This eliminates the state contention issues that occur when thousands of users try to interact with the same smart contract simultaneously. However, this resource-oriented model requires a complete rethink of how we discover counterparties, moving the complexity away from the chain and into a gossip network of solvers. The Intent-Centric Clearinghouse. Anoma replaces traditional transactions with intents, which are cryptographically signed outcomes rather than step-by-step instructions. In this system, you do not manually route a swap through 3 different bridges. You simply commit to a state where you own asset X and no longer own asset Y. Third-party solvers then compete to find the most efficient way to satisfy that intent, often bundling it with thousands of others to create a single atomic settlement. This design choice effectively turns the blockchain into a clearinghouse for state preferences, rather than a simple execution engine. The trade-off is a massive increase in off-chain computational overhead, as the network relies on these solvers to maintain a constant stream of counterparty discovery. This gossip-based architecture is what enables the protocol to settle intents across multiple different chains without the need for traditional synchronous bridges. The shift from execution to settlement. The real implication of the Anoma Resource Machine is that the industry is moving away from the monolithic execution model toward a distributed operating system for state. By decoupling the discovery of a transaction from its finality, Anoma transforms the blockchain into a matching engine where interoperability is a native property of the state model itself. This architecture addresses the liquidity fragmentation seen in 2026 by allowing any resource to be swapped for another regardless of its home chain, provided a solver can find the path. For developers and analysts, the focus shifts from optimizing gas on a virtual machine to optimizing the efficiency and decentralization of the solver marketplace. This design is either the blueprint for the first truly scalable cross-chain economy or a gamble on the ability of off-chain infrastructure to keep pace with on-chain demand. We should watch the performance of the first production intent gossiping nodes this quarter to see if solver competition can actually provide reliable settlement under real-world stress. Subscribe for more